This is a tutorial on how you can run your own AI video generator models locally on your desktop or laptop. No more websites with limited credits. No more websites with limited generations per day. No need to create multiple Gmail accounts. This solution doesn't even need a single Gmail account. Sounds too good to be true? No. I have tried it myself and it works. So let's get to it, and you too will see that this solution works. What will you need? I tested the solution on my own i7 6700 processor with 32 GB of RAM and a GTX 3080 GPU. After the initial install and model download, I was able to generate 4 HD resolution videos, 5 seconds in length, in about 290 seconds. The models can generate 720 resolution videos, but the Wan2.1 1.3b model claims it has been better trained for 480 resolution. To start, you will need to have an NVIDIA graphics card. The solution claims it is backwards compatible with even the GTX 10XX series. While the solution may work for GPUs with less RAM, I recommend at least 6 GB RAM on your GPU. The GTX 10XX series came with 2 configurations, a 3 GB and 6 GB version. You may be able to get the 3 GB version to work, but there may be more hoops involved to do so. Next, you will need a decent amount of RAM. You should be able to scrape by with 16 GB of RAM, but more is probably better. Then you will need Python version 3.10.9 or higher. The installation instructions use version 3.10.9. But I installed 3.10.10 and didn't have any issues. Since not everyone has Python installed, I will include a quick overview of its installation as part of this tutorial. Lastly, we will need Git to download the necessary repositories. Ready? Okay, let's go. We will start by downloading Git. Git allows you to download Git repositories such as the one that contains the Wan2.1 solution that we are trying to install. If you already have Git installed, skip this step. Open your favorite web browser and go to the Git download address. The link is in the description. Click on the Git for Windows /x64 setup. If you know what you are doing, you can download the portable edition instead. This allows it to be removed easily without needing to do an uninstall, but it also requires you to know how to add the Git folder to your system path. If you use the installer instead, it should update the system path automatically. Run the downloaded file to install Git. If there is an option to add Git to the system path, ensure the option is checked. Congratulations! You now have Git installed and with it access to the millions of Git repositories available on the internet. Next, we will install Python. If you already have Python version 3.10, skip this step. Open your favorite web browser and search for Download Python 3.10 for Windows. Select the top result that isn't a sponsored link. Scroll down the page to the Files section. Find the Windows x64 version and click on the name to download it. Once the file is downloaded, run the file to install Python. I suggest choosing the custom settings install and making sure the Add to Path, Install PIP, and Install Py are selected. Then complete the install by following the installer instructions. Now that we have Python installed, we can have a quick refresher on Python environments. Python environments are containers where you can load all your project-level modules, and those modules will be local to the project. That means when you want to delete the project, you just delete the project folder and the environment folder, and all the related modules will be deleted. No messy uninstalls needed. The downside? Yes, there is at least one, but there are ways to mitigate it. If each environment has its own modules, that means if different projects use the same modules, they will be present multiple times on your device. Usually this is not a problem if the modules are small, but when you have modules like PyTorch, which takes up a few gigabytes of space, you don't want to have a copy of it for each project using it. However, that discussion is beyond the scope of this tutorial. Maybe I will release a follow-up tutorial on how to avoid that later. There are also some drivers and toolkit which are intended to be installed outside of Python environments, and we will be installing a couple of those during this tutorial. So let's get to it. Open a command prompt as an administrator, and we are going to be installing the rest from the command line. To do this, go to your Windows search bar, type CMD, but do not press Enter. Windows should find command prompt. Right-click the found entry and select Run as administrator. This will ensure that we won't have any permission problems. The command prompt will appear. I suggest resizing the window so you can see more of it at once, but that is up to you. We will start by verifying that Python has been installed correctly and that it is the correct version. Type the word Python, followed by a space, then 2 dash signs, and finally the word version. Press Enter. This shows us the installed version of Python. If you get an error message, especially a command is not recognized error, it means the Python installation was not completed properly. If installed, usually this means that the checkbox to update the path was not checked and, as a result, the system can't find where Python interpreter is located. In such a case, add the folder where the Python exe resides to the path manually, or just uninstall Python and then reinstall it, making sure to check the Add to Path option. If the version reports something different than the version starting with 3.10, then you have the wrong version installed. This can happen because you downloaded the wrong version or you had a previous Python version installed. While you can have multiple Python versions installed at once and still make this solution work, the actual steps to do so are beyond the scope of this tutorial. Okay, so we have the proper version of Python installed. Next, we install the drivers and toolkits that need to exist outside the project environments. In our case, that is CUDA and CUDA toolkit. What is CUDA? Without going into details, since that could fill many tutorial videos, CUDA is the magic that allows software to talk to the GPU, at least when it comes to AI-related functions. Usually the CUDA drivers are then wrapped up into a module, such as PyTorch, to make it easier for software developers to use the various GPU functions. But we are getting ahead of ourselves. If you already have CUDA installed, skip this step. The CUDA drivers are system-wide, so you only install them once regardless of how many projects make use of them. To install the CUDA drivers and toolkit, if you don't have them installed, we need to head over to the NVIDIA CUDA archive page. The corresponding link is in the description. You will need to make an account if you don't have one, but it is free. Next, we select the version that we want. Most AI target version 11.8. However, I used the latest version for my install, version 12.9, and it worked fine. Then we select the target OS, in this case Windows. Next, we select the only option available for architecture, which is x86 or 64. Next, we select the Windows version. Select the version that matches your Windows. In my case, that is Windows 10. Lastly, we select local or network install. Either method can be used. Finally, we get a download button to download the file. If local was selected, this will be a large file around 3.3 gigabytes. If the network option was selected, the file will likely be small because it will download the contents during the install. Once the file downloads, run the file and follow the instructions on the screen. The default settings are fine unless you have reasons to change them. First part done. Now we return back to NVIDIA page and download cuDNN. As before, you will need a developer account to get access, but you can get an account for free. Link for the page is in the description. When selecting the version to download, pay attention to which CUDA version the download is for. If you downloaded, for example, the 11.8 version of CUDA, then you will need a version of cuDNN for CUDA 11. If you downloaded, for example, the latest version, such as 12.9, then you will need to get a version of cuDNN for CUDA 12. Next, we will need to select the specific download that we want. In this case, local installer for Windows ZIP. At this point, you may be asked for your account credentials and the file will download. Once the file has downloaded, extract the installer from the ZIP file and run it. Congratulations! You have installed CUDA Toolkit and cuDNN. If you have more projects that need it, you don't need to install these drivers again, since they are system-wide. To make it easy to eventually remove our project without leaving a mess, we will now create and activate a Python environment. Type py space -3.10 space -m space venv space and a name for your project environment such as Wan2.1. This command creates an environment based on Python 3.10. We can activate this environment by typing the environment name, followed by a /, followed by the word scripts, followed by another /, and then the word activate. Now, any modules that we install will be kept within the activated environment and thus can be easily removed when no longer needed. This also ensures that different projects can use different module versions without conflict. When you have an environment activated, the command prompt is prefixed by the environment name so that you can easily tell if you have an environment active and what the name of it is. Before we get to downloading the Wan2.1 repository, we want to install those libraries that we mentioned earlier, which wrap the CUDA drivers and make them available in Python. The repository assumes you already have these installed, so we will do that first. Since we have an environment active, these modules will be kept within the environment. Type pip install torch equals 2.6.0 portrition torshoyo -dos index SURL https://download.pytorch.org/whl/test/cu124. The link is in the description for your convenience. This will download the PyTorch components for CUDA 12.4. There aren't any PyTorch libraries for the latest version of CUDA yet, but your more updated CUDA drivers will work with this version of PyTorch. If you are using CUDA 11.8, change the last part of the command to cu118 instead. Sit back and relax while the PyTorch components download. The whole solution is a few gigabytes, so it will take a while. Grab a coffee, a tea, or a snack. Once PyTorch is installed, you can finally get to cloning the Git repository with the actual solution. A Git clone just means downloading a copy of the Git repository to your local computer. To git clone the Wan2.1 repository, we type git clone https://github.com/deepbeepmeep/wan2.1.git. The link will also be in the description for your convenience. This repository does not include all of the models, so it should clone quickly. Now we can change into the newly created repository folder by typing cd wan2.1. Before we can start the solution, we need to download all of the dependencies, besides PyTorch, that the project requires. Luckily, this is easy to do in Python. To download all the dependencies, we type pip install -r followed by the word requirements.txt. This tells pip, the Python module installer, to download all modules specified in the requirements.txt file. Go to refill that coffee cup or tea cup because there are lots of dependencies that it needs to download, but we are almost there. Once the dependencies are all downloaded, we could run the solution now. However, there are two more short steps that we can do to make the video generation much faster. We can install Sage Attention and Sage2 Attention. What are those? I have no idea. All I know is that they are some sort of optional performance optimizers which speed up the video generation process. There is actually a third one, but it can be tricky to install on Windows, so I skipped it. If you are interested in trying it, the repo has instructions for installing it. Type the following to get Sage Attention: pip install triton-windows, and then pip install Sage Attention, all one word, equals 1.0.6. That is it for Sage Attention. Now for Sage2 Attention. We need to do another pip install, but the URL is so long, so check the description for the link. And we are done. Ready to fire up the solution? Type python wgp.py. Wait for the script to do its thing and you should be rewarded with the URL in the console. Likely this will be a localhost URL with a specific port number. This is the URL of the user interface. Copy and paste the URL into your browser and you will be rewarded with the Wan2.1 user interface. At the top of the page is the model selection. By default, the Wan2.1 1.3b model is selected, which is the Wan2.1 model specifically targeted at commercial-grade GPUs. However, the user interface does have other options that you can try. Depending on your GPU and RAM, some of these other models may or may not work. The rest of the page has all of the configurable parameters for the video generation. The meaning of each of these parameters is beyond the scope of this tutorial. Play with the NC, or read about them online, or ask one of the many AI bots to explain them to you. Okay, with the Wan2.1 1.3b model selected, enter a text prompt for what you would like to generate. Adjust any parameters and then press Generate. Now, go watch an episode of your favorite TV show or something, because the very first generation will take very long because it triggers the download of multiple model files which are multiple gigabytes in size. Depending on the download speed available, this can take a long time. However, this only happens on the first generate prompt. Once the models are downloaded, each successive generation request will be much faster. On my i7-6700 with 32 GB of RAM and a 10 GB GTX 3080, I can generate 480 resolution videos, 5 seconds in length, in about 290 seconds. The model does support up to 720 resolution, but it has been trained more extensively on 480 resolution, so you may get better results with the 480 resolution video and then finding a video upscaler to upscale it. Obviously, increasing the resolution or the video length will increase the generation time. So there you have it. Wan2.1 1.3b is now running on your device locally, and you can use it for unlimited video generations. If you found this video useful, please give the video a like and press the subscribe button to get my other great content. Ta-ta for now, and see you in the next video.
I know these videos don't have great production quality, but they do have a lot of useful information. So please, appease the YouTube algorithm goddess by casting the subscribe spell and then blasting your eldritch blast at the like button. It'll really help me out.